In the last decade, interdisciplinarity has become a keyword in most of the debates about education, labor market, and academic research. New fields and new needs are arising, and the previous form of organization of knowledge are perceived as too rigid and not consistent with the reality of research and work. Using a metaphor, knowledge cannot be seen anymore just as a puzzle where different pieces fit together with precise and visible borders. The acronym STEM is used to refer to a teaching approach that integrates content and skills specific to science, technology, engineering, and mathematics. It was created to stress that the educational systems should take seriously into account the interdisciplinary integration between scientific disciplines and technology. In our project, we refer to STEM integration in education as working in complex situations on tasks that require students to use knowledge and skills from multiple disciplines. In the definition of STEM, there is often vagueness about how this integration actually takes place. What is the role of disciplines in this new paradigm? What are their relationships? What does it change in traditional teaching if we adopt this perspective? 3 different teaching approaches are usually taken into account: multidisciplinarity, interdisciplinarity, and transdisciplinarity. To show the differences between those approaches, we present 3 different scenarios of a lesson on the greenhouse effect. Teacher Elena is teaching 1 hour of chemistry related to the greenhouse effect, about hydrocarbons. Teacher Ricardo introduced the math concepts and methods useful for greenhouse effect. Teacher Dimitris presents the technology used when dealing with greenhouse effect studies. They are adopting a multidisciplinary approach. Teacher David communicates to the students the most important causes and consequences of the greenhouse effect within the context of environmental education. He stresses that it will contribute to saving the planet without explicitly focusing on any structured disciplinary content. He shows images and data to highlight evidence of the impact of humans on climate change. This is an example of transdisciplinarity. Teacher Sarah analyzes trends using data from NASA about global warming. She discusses with her students the comparison between the graphs of solar activity, one possible variable that can impact on global warming, and the raising of the temperature. This leads to talk about a problematic issue. What does it mean to put in relation physical phenomena by interpreting analysis of data and models? This is an example of interdisciplinarity. So, what is the difference between multi, inter, and transdisciplinarity? Multidisciplinarity involves encyclopedic or additive juxtaposition, or at most, some kind of coordination, but it lacks intercommunication and disciplines remain separate. Transdisciplinarity is transcending, transgressing, and transforming. It transcends the scope of disciplinary worldviews through an overarching synthesis. Interdisciplinarity is integrating, interacting, linking, and focusing. As you know, in our approach, we focus on the latter. There are many typologies of interdisciplinarity. From our perspective, in interdisciplinarity teaching, discipline should be involved at least in a process of explicitation of the features that determine their identities. The interaction between them produces exchanges, debates, and innovations. This process leads to rethinking the disciplines themselves and their boundaries.